The program is powered by Automation Trader, your trusted supplier of industrial automation components and solutions. New, used, refurbished parts, or maybe those discontinued from production. Contact us. We'll find a solution.
Here's the terminal group X1, and I will put individual terminals for live wire, neutral, and earth, couple end terminals as well. Now I will put the terminals on terminal group X2, so for 24 volts. The first terminal is fused, so it's possibility to replace the fuse or disconnect the whole circuit. The end terminal as well, and one by one all others. So here we have terminals for 230 volts AC and 24 volts DC. I won't install the RCD because I already have the RCD in my distribution board. This have completely no sense to install two RCDs in series. I will say only that the RCD is protecting the user from electric shock. This device works on the Kirchhoff law, so it's checking if the current is same on a live wire and neutral wire. These currents must always match. So input current must be always same as the output current. If there will be any difference between these two currents, built-in coil will trip the switch and isolate the power supply. It usually takes milliseconds. So I won't install this in this panel as explained before. I will install the isolator first. And what is the difference between isolator and circuit breaker? So the difference is that the isolator have no mechanism inside to check the current flowing through the isolator and disconnect the circuit if necessary. This type of isolators are only for mechanical isolation by operator or user. The circuit breaker have a built-in the thermal, I will say, sensor, what is checking the current flowing through the circuit breaker. The mechanism will automatically trip the switch and isolate the circuit. This one is the type B with the maximum current of 4 amps. So that's mean if the breaker will work with a higher current than designed, it will automatically trip. The current will be a bit different than 4 amps, but this needs to be checked in a manual. This type of isolators will never trip by itself. So why we're using the isolators? The isolator have a much bigger space between the contacts inside the switch, so the isolation is much safer than on circuit breaker. That's why we're using isolators right in the beginning of the circuit. Of course, we have many types of the isolators, like rotary isolators with the handle, these types, but we're gonna use this type in this panel. So I will install the first element on the rail, and straight after this I will put the circuit breaker. This will be just to supply the 24 volts DC power supply. I will do some wiring now, and we're gonna start first time our circuit. I will use black wires for 230 volts AC. This is a small difference to the schematic. There were the red wires for 230 volts, but I will use the black ones. The red ones I will use for signal wires. I will leave some space here because definitely we're gonna add some circuit breakers here. Every earth terminal have a connection to the rail. Because the DIN rails are secured into aluminum sheet, all rails are earthed. For positive 24 volt I will use a red wire, and for negative or 0 volts I will use the blue with the white line. The colors may be different in different panels. For example, you can see light blue for low potential and navy for high potential. I've seen many different solutions, but always this information should be included on schematic. All connected same as on the schematic, same markers as on the schematic, Q1, F1, PSU1, all wires connected same as on the schematic. Terminals are marked same, so we can move forward. In the next episode, I will talk a bit more about safety circuits. So for example, how to install the emergency stop button. Theoretically, that's a very simple issue, but sometimes the circuits are really complicated. That's everything for today, and see you next time.